All right, in lesson 15, we're going to try to prove, or we are going to prove the Pythagorean theorem, that a squared plus b squared equals c squared. And what we're going to do is we're going to use a compass, and we're going to make a perpendicular line with the hypotenuse from point C. And if you look here, this right here at the corner makes a right angle. So what I'm going to do is I'm going to put my right angle there, and I'm going to line it up with C. Okay, so then I know that it's a perpendicular angle. Perpendicular means that it makes a right angle. Okay, and it would look something like this. Oh, draw it all the way over there. Did you guys see that? I line up the hypotenuse where the right angle is and line it up with C and draw a line all the way over. Okay, so this is a right angle right here. We're going to make that D. Okay, and that's what we have here on the bottom. The whole length from A to B is side C. The side across from A is A, and the side across from B is B. Now, I'm going to show you this in another way with a note card. Okay, so I'm going to do the same thing. First, I'm going to draw a diagonal across the note card. Okay. Then I'm going to make the right angle again, the perpendicular line. So right now we have two right triangles. And I'm going to draw my right angle again. Just like this. So this is the same thing, just bigger, right? And I'm going to cut it apart so you guys can kind of see these separate, because what it's going to look like when I cut it apart is at the bottom of your page. So we're going to end up with three triangles. Okay? And what could you guys tell me about those triangles? What do you think you might know about those triangles?
Similar.
You think they're similar?
Yeah.
Okay, what else?
They're all triangles.
Well, yes, they are all triangles.
They're all right.
They're all right triangles. Okay, so I have my three triangles. Like this, and let me go like this. Okay, so we have our three triangles. And so what we're going to do is we're going to use them to prove this. So we know they're similar, and they all have a right angle, right? That's what you guys told me. Are they all similar? Okay, so is this one here similar to this one, if I could draw correctly? Would they be similar? Yes? Okay, and is this one similar to this one? We can check all the corners, right? Okay, so then are these two similar to each other?
Yeah.
Yeah? By what property? Do you guys remember the name of that property? It starts with a T. Transitive property. Like if this one is similar to this one, and this one is similar to this one, then these two are similar because of the transitive property. Okay? So, we're going to use this to identify more of this information. So I'm going to take these away now. We're going to use this. So if we consider triangle ADC, or and ACB right here, okay, can you write a statement about corresponding sides being equal in ratio? So, what do you guys think? So, this side and this side are corresponding, correct?
Yes.
So, if we label this X, then it would be X over B equals these two, right? Right? B over C. correct? Okay. Then we could solve for x. So we could cross multiply. So we have x times c equals b times b. Yes? So xc equals b to the second. We could solve for x by dividing by, by c on each side. So x equals b squared over c. Alright, we just solved for x. Okay, and now we're going to use these two triangles and do the same thing. Okay, so if we use, well, what did they didn't use that again, they used y. So a over c, right, these sides are corresponding, they're the hypotenuse of both of them, equals, I'm going to put x down here, or y down there, sorry guys, equals y over a. So if we cross multiply again, we have a times a equals cy. So a squared equals cy. If we solve for y, we divide both sides by c. Y equals a squared over c. Okay, so we know that if we move this side on here and this side on here, it's going to be equal to c. Everybody good with that? So if I take this, let me show you, and put this here, and put this here, it equals c. You guys cannot see that. Remember when I cut it? I had x and I had y and it equals c. Everybody good with that? So I know that x plus y equals c. And I have solved for x and I have solved for y. So I can plug in for those things. So x, okay, would be b squared over c. I just took this one and plugged it in here. And I'm going to take this one and plug it in here. A squared over c equals c. Now I want to get rid of the denominator of c. So what should I do to get rid of that denominator? How do we get rid of a denominator? We're going to multiply by whatever the denominator is by everything. So I'm going to multiply by c, multiply by c, multiply by c. Okay? So the c's end up canceling each other out here and here. Okay? So on the very far left, we're left with b squared plus a squared equals c squared. So this is another proof, and we can rearrange this so that it looks pretty like we're used to. A squared plus b squared equals c squared. Okay, it doesn't matter what order these are in over on the left side. Okay, but that shows us the proof of the Pythagorean theorem in another way. Some of you have already seen it in one way. This is another proof for it. Okay? Let's go ahead and turn the page over. Okay, so we're going to apply this to something that we have, or to a geometric consequence. We're going to explore another thing with it. So we have this, and if we drew squares on each side, okay, it would look like this. Okay, so if I drew a square here, it'd be something like this, and we'd have one gigantic square out here, and we'd have one square over here. So, but it would look like this. Okay, and when we draw this, you can kind of see that it's colored, and I'll color it a little bit better for you. The light one would move up here and go into the light part. The dark one, the purple, would fit right here if we cut it apart and put it there. Everybody good with that? So if we took the purple part and cut it to fit in there, they would fit. And then this light one down here at the bottom would go and fit in there. They're the same size. Okay? So the squares on the two sides of the triangle equals the square on the hypotenuse. So the square of A, see that's a square? Isn't it A times A gives you the area, right? Plus the square of B, B squared, equals the square of C. So this is another proof of the Pythagorean theorem. So you can see that you can take the pieces apart and move them around a little bit more easily. And then there are two videos that I'm going to post that you will need to watch at some point to help you with this, to kind of show you another proof, and I'll post those on the page. Right now, I want you to go back to the very first triangle in your packet. Okay. So the altitude, this is called an altitude because if we turn it this way, see it kind of goes up. Ooh, kind of goes up. Alright, so this is the altitude. Okay, it makes a right angle with the hypotenuse, and it divides these two into segments. This hypotenuse into segments, which we saw with the pink triangles that they were equal. Okay. So we can prove with those triangles similarity here. We can move them around. Physically, we did move them around to show that they were similar. But then we can also prove with geometric shapes on this one that the squares on, or the squares on each of the legs equals a square on the hypotenuse, which is just what the Pythagorean theorem says. Okay.